So let's start with the COD test. So the outline of COD test is this. We will understand what is BOD, what is the difference between BOD and COD, and how to measure COD. What does COD by BOD ratio mean, or BOD by COD ratio mean, and what is the interference in COD test, and what are the type of titrimetric reactions. So let's understand what is BOD, that is biochemical oxygen demand. So in biochemical oxygen demand, what is happening? So the organic matter is getting oxidized and the oxygen is getting reduced with the help of microorganism. So what we can say, the organic matter is decomposed or degraded by the microbial community. So this is biodegradable organic matter. This is biodegradable organic matter is oxidized to carbon dioxide and oxygen is reduced to water, and due to this the microbe is utilizing organic matter, so that's why as a product we are getting biomass means microbes here. So this is biochemical oxygen demand. So the oxygen required here, the oxygen required here this oxygen in this process, this is called biochemical oxygen demand, or specifically if I say, it is called ultimate BOD. So to calculate this, it requires at least 5 days or 3 days. 5 days, it requires 5 days, and in India we generally calculate it in 3 days at 27, I think 27 degrees Celsius. So the biodegradable organic matter is getting oxidized with the help of oxygen, uh, which is oxygen is utilized by the microbe to oxidize organic matter, and the oxygen is getting reduced to water, and in this process the microbes will grow and they will produce biomass. So this is uh, this is actually biochemical oxygen demand. So the same process is done with the help of oxidizing agent. The same process, the organic matter is getting oxidized to carbon dioxide and other oxidized products, and the oxidizing agent is getting reduced, but this is with the help of oxidizing agent. So here the oxidizing agent is dichromate K2 Cr2O7, sorry, and the oxidizing agent here is, the reduced compound will be so this will be reduced to, this oxidizing agent will be reduced to this is Cr6 plus, it will be reduced to Cr3 plus, that is called chromate ion. So in this process the organic matter is oxidized and the oxidizing agent is reduced, and in that process this chromate ion is quantified. So how much chromate and chromium is formed that we will evaluate with the help of titrations. Let's understand what is the theory. So the chemical oxygen demand is defined as the amount of specified oxidant, which is here dichromate K2Cr2O7, that reacts with sample under controlled conditions. The quantity of oxidant consumed is expressed in terms of oxygen equivalence. So the amount of oxidant consumed, so the amount of dichromate consumed is expressed in terms of oxygen equivalent. So because of its unique chemical properties, dichromate ion is a specified oxidant. So we have to note some things. So in COD, here the organic matter is both biodegradable organic matter plus non-biodegradable organic matter. So which can be oxidized with the help of microbes and which cannot be oxidized by the microbes. Both will be oxidized in COD. So COD value will, in general, COD value is more than BOD. Generally, it can be equal also. So both organic and inorganic. Inorganic means biodegradable organic matter plus non-biodegradable organic matter plus inorganic compound. Inorganic components of sample are subjected to oxidation, but in most cases the organic component predominates and is of greater interest. So we are concerned about the organic components because that can be degradable and that can be degraded biologically. That's why they are of more interest. In COD analysis, hazardous waste of mercury, hexavalent chromium, sulfuric acid, silver, and acids are generated. So this is the environmental concern. So if the chloride contribution to COD is negligible, then HgSO4 can be omitted. So that we will understand in the interference part. How to measure COD. So what is happening? The dichromate must understand like this. So we will take the COD vials. So we'll take 2.5 ml sample for which we need to calculate the COD. So this is the 2.5 ml sample we will take. Then we will take 1.5 ml 1.5 ml digestion solution. This is dichromate solution. Digestion solution. Then we will take 3.5 ml of sulfuric acid solution. Acid solution. Then we will close it with cap and you will shake it. After shaking it, you will keep it for digestion. Keep it for digestion for at 150 degrees Celsius for 2 hours and then allow it to cool and then transfer the content into the conical flask. Transfer the content into the in the conical flask and use ferroin as an indicator. Ferroin as an indicator. Then we will titrate it with FAS. So in burette, in burette, take FAS, ferrous ammonium sulfate, which is a reducing agent. This is burette stand, and you can put the conical flask here and titrate. So what it will do, so this we will do for blank and for the sample. For the blank and for the sample. Blank means distilled water, sample means for the sample for which we need to measure the COD. So when we are titrating, what is happening here? So the first reaction was, there are two reactions that we need to learn. So the organic matter is oxidized, and during oxidation the organic matter is oxidized and the plus 6 chromium ion is reduced to chromate ion. So if in the blank the Cr6 plus reduction will be very less. So in the blank the Cr6 plus will be majorly in the Cr6 plus form, while if the wastewater has organic matter, some fraction of Cr6 plus will be in Cr3 plus form and some will be in Cr6 plus form. Now let's understand it. So so the FAS, what FAS will do? FAS will reduce the leftover Cr6 plus to Cr3 plus form. We will understand it in the next slide. So let's understand it. For blank, what is happening? Majorly Cr6 plus, let's say it was 100% in the digestion solution. So nearly you will get Cr6 plus after digestion, 100%. So the blank will have, suppose if this is blank, and this blank has 100% Cr6 plus. So to reduce 100% Cr6 plus, more titrant volume is required. More titrant, let's say 13 ml titrant is required. And let's say, but for sample, now we'll understand it for sample. For sample, initially 100% Cr6 plus was there initially, but Cr6 plus is oxidizing organic matter and it itself getting reduced to Cr3 plus form. So let's assume 60% is reduced to Cr3 plus and leftover is only 40%, which is in Cr6 plus form. So the leftover which is in Cr6 plus form is only 40%. So what is happening here? The conical flask, we transfer the content, so the FAS will be titrated. FAS will reduce the 40%. So the FAS will reduce. FAS will reduce only 40% of the CR6 plus. So let's say the volume, what we will do here. So from with the help of burette, we'll titrate the solution which has only now 40% CR6 plus, and rest chromium is already in chromatin, that is Cr3 plus plum. So FeS will not react with this ion. The FeS here in the burette will only titrate with the 40% Cr6 plus, and so less volume will be consumed. So let's say the volume of FeS consumed is here. Volume of FeS consumed let's say how much, 8 ml. In blank it was 13 ml we assumed, and in the sample volume of FeS consumed is 8 ml. So because there was less Cr6 plus, so the difference will tell us how much. So the difference will tell us how much chromium has been reduced to Cr3 plus form. So that will tell us the chemical oxygen demand. So this is the calculation. So here B was 13 ml, A was 8 ml. Molarity is something that you will the molarity of FAS that we make it in the lab, and this is the milli equivalent weight of oxygen, and milliliter of sample taken. We took 2.5 ml of sample. So from this formula we will get it as COD in milligram of oxygen per liter. So this is how we calculate the COD. So what is the ratio of COD by BOD or BOD by COD ratio mean? So COD oxidizes non-biodegradable organic matter plus biodegradable organic matter, and if I divide it by BOD, biodegradable organic matter, so if COD by BOD ratio is large, if COD by BOD ratio is large, it means non-biodegradable organic matter is more. If that means if non-biodegradable organic content is more, then it cannot be treated biologically. Then this wastewater cannot be treated biologically. So this ratio tells us this thing. What is TOD? TOD is a measure of amount of oxygen consumed by all elements in the sample when complete total oxidation is achieved. So in water we have so many things like iron, manganese, all the compounds of nitrogen and chloride. There are so many compounds. So for oxidation of all the compounds, whatever is the oxygen required, that is called TOD. So now we will understand what are the interference in COD test. So the most common interferent is chloride ion. So chloride, iodide, bromide. So these ions may interfere in the COD test. And the main thing is the chloride reacts with the silver ion to precipitate it as silver chloride. But and the silver is used in COD test as a catalyst, so it inhibits the catalytic activity of the silver. And same thing, bromide, iodide, they will also do the same thing. And so these bromide, iodide, and any other reagent that inactivates the silver ion can interfere similarly. Uh, such interference such interference are negative in that they tend to restrict the oxidizing action of dichromate ion itself. However, under the rigorous digestion procedure for COD analysis, chloride, bromide, or iodide can react with dichromate to produce the elemental form of halogen and chromic ion. Results then are up on the higher side. This point we can understand it as. So what is this point saying? This chloride, iodide, and bromide. So these are in reduced form, so they are oxidized to their oxidized. Let's write it like this. Chloride, iodide, bromide. They will be oxidized to elemental form, and this will be reduced to Cr3 plus. So this is oxidation, this is reduction. So it is getting consumed. So this is consumption of dichromate because of chloride, iodide, and bromide ion. So consumption of dichromate solution. So why are we providing dichromate? For the oxidation of organic matter, but here these compounds are utilizing our dichromate solution. So this is causing interference. This difficulty caused by the presence of chloride ion can be overcome largely but not completely by making the complex with mercuric sulfate HgSO4 before the refluxing procedure. So before this procedure, what we will do, we will add HgSO4. That will form the complex with these compounds, not fully, but up to some extent the interference can be reduced. So this is the idea behind this. So this is the idea for adding HgSO4 into the uh, acid reagent, like sulfuric acid reagent. This PPT, this slide was about interference, and the last slide is regarding the titrimetric reactions. So in titrimetric reactions, we have four categories. So the COD and BOD, we can see the organic matter is oxidized by either oxygen or dichromate, and then Organic matter may be oxidized to CO2 or some other thing, and here it is reduced to either H2O or chromium 3 plus. So this is oxidation, this is reduction, so this is a redox reaction. So the COD and BOD are the redox reaction. Complexometric reactions is hardness, in which EDTA forms complex with calcium, and acid-base neutralization reactions is alkalinity, and in which the acid is used as a titrant, and precipitation reaction is chloride content, in which Ag reacts chloride reacts with silver to form AgCl. So this is precipitation titration. So this was about COD test. Thank you.